Welcome to the Math Classroom. If you missed our previous lessons on Riemann's sum, definite integral, kindly find the link in the description below. Our lesson today focuses on the fundamental theorem of calculus. So we are taking it into directions, and the first part today we are saying if f of x is a continuous function on this interval which is ab, then part 1 says that if f of x is on this interval is defined by this. So you have it defined by this. So this is the definition. What does it mean? It means that the derivative of f of x is equal to f of what? X. For all x in this interval. What does it mean? So let's look at what that definition implies. So we are saying that if I have the function, so this implies that the derivative, which is my derivative dx of the integral from a to x of f of x dt is equal to f of x. This is what it means. So let's look at this example. So I have an example. I want to find our first example says find the derivative of this function. So in finding for the derivative, we are saying that our f of t, this is our f of t. So our f of t, it's equal to this. So f of t is equal to that. And this is continuous on this interval. So by the fundamental theorem of calculus, what it means is that the derivative of this is equal to that. So let's see how did we arrive at this. So what it means from here is that the derivative d of the x of the integral of from what -1 to x of f of t dt is going to be equal to d dt of our function as what? F of what? T. Okay. And this is from what? -1 to what? X. So if you simplify, what do you have? You realize that you have the derivative with respect to s, d with respect to s from what? F of x minus what? F of -1. And this will give you what? F of x. F of what? X. Because don't forget, we said the derivative of this is equal to that. So this is giving you f of what? X. So because it's giving us f of x, what do you see? From our definition here, we said the derivative of this is equal to that. So this means that this is equal to this. If you take the second example, so let's look at the second example. You realize that with the second example, where you find the derivative of this with respect to that, here, what is our f of t? This is our f of t. So from here, you realize that my f of t here, so from here, my f of t is going to be equal to square root of what? T cubed plus 1. Okay, plus 1. Okay, alright. So if you take the derivative as well, t cubed, so you realize this is cube, I have cube here, this is also cube as well, so cube. Okay, so you realize that from this, let's find the derivative. If you take the derivative, what do I get? So I have d, I have dx of the integral x towards 5 f of t. And what is f of t? F of t is square root of what? T cube plus 1 dt. Okay, if it simplify this, what do I have? I have dt of what? F of t, my big F of t, and the interval is from what? X towards 5. Okay, so from here, what do I have? This implies that I have what? D over dx of what? F of 5 minus what? F of what? X. This is all you have, which is equal to, so you realize that this is a constant, and because this is a constant, it goes to 0. Just like we had here, that this was a constant, so it goes to 0. If you differentiate a constant, you get 0. So then this is going to give you minus what? F of what? X. So this implies that my what? F of x, the derivative of this is giving me minus what? F of what? X. What do you notice here? You notice that the answer is no more what? F of x. So from here, you notice our answer is no more F of what? X. Okay, but this time our answer is what? Negative of what? F of what? X. Why? Because you realize that x is at the lower bound of the integral. So that's when x is at the lower bound of the integral, then it becomes what? Negative. It becomes what? Negative compared to when x was at the upper bound, then it was equal to this. So we have this. This is x at the upper bound. Then this is when x is what? X is at the what? Lower bound. Lower bound. Then we get a result as this. So this for the first part of fundamental theorem of calculus. These are the results we have. So in our next lesson, we'll look at the part 2 of our definition of fundamental theorem of what? Calculus. Till then, kindly stay safe.